There have been far too many accidents and fires related to biodiesel production. Because the process of making biodiesel is relatively simple, does not mean that it does not involve hazardous chemicals. Fires and explosions are the main type of serious accidents that have occurred producing biodiesel, and methanol is consistently the reason. This video attempts to improve the awareness of methanol in biodiesel production so that future accidents can be avoided. Methanol, technically known as methyl alcohol, is a colorless alcohol with the chemical formula CH3OH. It is the simplest alcohol with its molecule only having a single carbon. Methanol is a volatile solvent widely used as a feedstock to produce chemicals to make adhesives, plywood, windshield washer fluid, and many other products. About 40% of the methanol on the market is used as a fuel or fuel additive. It is also used for producing biodiesel via the transesterification reaction. Methanol is highly toxic when ingested, inhaled, or even absorbed in the skin. Ingestion of even 1 or 2 ounces of methanol may cause death, and lesser amounts are known to have caused irreversible blindness. Since methanol absorbs through the skin and other tissues directly into the bloodstream, users must not breathe methanol vapors or allow vapors or liquid to contact skin. Personnel working with methanol must wear protective clothing, chemically resistant gloves, a breathing mask that captures organic vapors, and a full face shield. The cartridge in the breathing mask should also be changed regularly. Although understanding the toxicity of methanol is clearly important, the single largest safety hazard of methanol with biodiesel production has proven to be that it is an easily ignited liquid and sometimes explodes in air. Methanol burns with a low temperature flame that may be invisible and is slightly heavier than air, so that it may migrate near the ground and collect in confined spaces and low-lying areas. In certain specific circumstances, methanol vapor may explode rather than burn on ignition. Here is a demonstration that shows part of the reason methanol can be so dangerous.
Hello, I'm Keegan Duff with the University of Idaho. The following are a series of simulated industrial accidents. This 300-gallon reactor tank we use to make biodiesel. For our purposes today, the tank is empty and there's no fuel load except what we put on externally. This fire is with anhydrous methanol. This fire is not visible to the human eye. An operator could easily walk up to the fire and be engulfed and not even realize that there was a fire. I could feel the heat waves coming off of the reactor, but I can't actually see any of the flame. It's essential for any biodiesel plant using ethanol or methanol to have a monitoring program to detect the presence of vapors. It's also essential any firefighting team that's going to put out a fire with methanol or ethanol to have access to infrared cameras.
A good start to properly handling methanol is to carefully read the Methanol Institute's Methanol Safe Handling Manual, which is available on their website. It is also important and typically required to have a Material Safety Data Sheet, or MSDS, for methyl alcohol available in a prominent location where methanol is being stored and used. Federal regulations require a Process Safety Management, or PSM program, if more than 10,000 pounds, or 1,517 gallons, of methanol is present in a production facility. All but the smallest of plants have more than this, but even small plants should implement a program for employees. Methanol must be stored in a well-ventilated, dedicated location where it is protected from heat and ignition sources. Methanol is an electrically conductive polar compound, so all storage materials, including totes and drums, should be grounded to avoid hazards associated with static discharge, and all electrical systems must be fully enclosed and explosion-proof. Plastic containers cannot be grounded and should not be used for methanol. In recent years, attention has been drawn to the hazard of using personal electronic items, such as cell phones and laptop computers, in potentially explosive atmospheres. The energy necessary to ignite methanol vapors may be similar to the energy produced by static electricity and by sparks generated by low-voltage electrical devices when they are turned on. As a rule, electronic devices such as cell phones and laptop computers should not be used within 20 feet of a potentially explosive atmosphere. Normally, methanol vapor, being only slightly heavier than air, will dissipate from ventilated locations, but do not expect it to dissipate from non-ventilated locations and enclosed spaces. The concentration of methanol in air necessary for combustion is approximately 4 times greater than that for gasoline. However, methanol releases less vapor than gasoline, and the temperature of methanol must be elevated in order to generate vapor concentrations necessary to support combustion in air. In order to prevent the methanol from absorbing moisture, it must be stored in a sealed container. The sealed container should have an allowance for thermal expansion. Otherwise, changes in temperature may cause the methanol to expand and rupture the container. Methanol containers are also subject to boiling liquid expanding vapor explosion when heated externally. Methanol storage requires appropriate secondary containment. The National Fire Protection Association standards require secondary containment of at least 110% of the volume of the largest methanol storage tank, but best practice dictates considerably more. Methanol is totally miscible in water and can be diluted with 4 parts water to 1 part methanol and still be considered to be a flammable liquid. This has important consequences for firefighting. Insufficient freeboard within the secondary containment area can result in overflow and a so-called running fire. Running fires are difficult to control. Methanol storage tanks should be labeled with a label that includes a hazard symbol. All piping and valves subject to carrying methanol should be consistently labeled, and direction of flow should be indicated. Each piece of plant equipment needs to be evaluated for safety. Operator and employee safety training is essential. Understanding the basics of the entire process, access to material data safety sheet information, and knowledge of each material used is necessary for every employee. A variety of precautions must be observed during the production of biodiesel. For instance, it is desirable to preheat the waste oil prior to the trans-esterification reaction. This must be done carefully to prevent oil spattering and accidental ignition when the catalyst is added. A closed reactor, whether batch or continuous, is preferable to a reactor that is open to the atmosphere. Temperature control throughout the process is critical to safe and efficient operation. If the temperature rises too high and agitation is too vigorous, then fire and/or explosion are possible. If the temperature is too low and agitation too gentle, then the reaction will not go to completion. The main reactor and other processing equipment will be laden with methanol vapors at various times during biodiesel production, and the best practice is to transfer all methanol-laden fuels via tubing into closed vessels and to vent all vessels to the outdoors. Methanol fumes will also be present when glycerol is drained from the reactor and when raw biodiesel is pumped from the reactor to wash tanks, especially if these fluids are drained while hot. Both glycerol and wastewater will contain significant methanol. Never grind or weld a container that contains or used to contain methanol or glycerol. Methanol recovery has some inherent safety problems and should only be carried out by advanced producers who fully understand the safety issues involved with handling methanol and hot liquids. Methanol fires are best extinguished by oxygen starvation with dry chemical powder, carbon dioxide, and alcohol-resistant foam. It is good practice to have 2 fire extinguishers at opposite ends of the workplace. When using a portable extinguisher, it is necessary to aim at the base of the flames, not at the flames themselves. If ignited, methanol vapor can flash back to its source. Water is a second choice to extinguish a methanol fire. Water in the form of a fine mist will absorb vapors, quench heat, and provide a curtain shield for upwind advancement. However, with large methanol pool fires, the volume of water must be 4 to 5 times the volume of the methanol pool, and secondary equipment should be capable of holding a volume 4 to 5 times larger than that of the methanol pool. Biodiesel production plant is a chemical plant and must be treated accordingly. There is nothing more important than the safe handling of methanol in order to protect your health and that of your coworkers, your workplace, the environment, and your community.